All right, so it turns out made a video, made a podcast, talked a lot during it, and the thing did not record the sound of my voice. So we're going to do this again. I'm not going to write anything. I'm just going to press play, and we're going to go through this, and I'll just talk. Sorry about that, guys. So we're doing applications of trig function 4.8. And so since we're doing application trigs function 4.8, one thing we talked about in 4.7 was inverses. And so with these inverses, let's first take a look at regular sine inverse. We were limited to quadrant 1 and quadrant 4. Here are just a couple of values. Just a reminder, remember that our range was from negative pi to pi over 2. The theta was an angle, and sine of theta gives us a length. So whenever we do inverse sines, we have to use the length. So if we use negative 1, it gives us the angle of negative pi over 2. Looking at cosine, we're restricted to quadrants 1 and 2. So for cosine here, let's do the cosine inverse, keeping in mind that we're taking the cosine inverse of the length. Let's say the length is 0. What would that be? That would give us the angle measure of pi over 2. So moving on to this third one, tangent. Tangent shares the exact same thing as sine. However, rather than including negative pi over 2, we will not include negative pi over 2. So taking a look at inverse tangents, we had a nice little trick for pi over 6 and pi over 3. For pi over 6, there are 2 3's in 6, and so we use root 3 over 3 as the tangent. It's a nice little memory trick because the only 2 tangents we'll get is root 3 over 3 and root 3. So that being said, we're only going to look at root 3 over 3 for pi over 6 and all pi over 6. For pi over 3 and all reference angles and coterminals of pi over 3, that will be root 3 as a tangent. We're not going to do any practice with inverses. We're going to just take a look at 4.8 now. So one part of 4.8 that we have to do is looking at a right triangle. And so we label triangles as usually ABC. It could really be any 3 letters. But the angles will always be capital. That's one thing to know for certain. Angles will always be capital, while the sides will always be lowercase. And so with that being said, we have the angles as capitals, the sides as lowercase. We're going to label this triangle ABC. So since this triangle is labeled ABC, we're going to use the known information. So I know that angle A is 12.7, and I know that side A is 19. One thing I also know is for angle C, it's 90 degrees. And so I'm going to leave C to be 90 degrees. Now, how many degrees are in a triangle? Think about it. That's right, 180. So when you add up all 3 angles, it gives us 180 degrees. So the way we find this is we do 180 minus 12.7 minus 90. With that being said and done, some people like to use a calculator. Some people can do it in your head. Think about it in your head. What do you think? 77.3. Oops. Oh yeah, I remember I had a little error here. So 77.3 degrees will be angle B. Now, let's look for sides A, B, and C. To find sides A, B, and C, what we're going to do is trigonometry. Now, we know side A. Side A is 19. That's easy because that was given to us. To find side B, what we're going to do is we're going to look at either using cosine, sine, or tangent. Now, what trig function involves the angle, the opposite side, and the adjacent? I'll let you think about that. Tangent. If you guessed tangent, good job. So tangent is the one that we use. So with tangent of 12.7, that's our angle. We're going to equal it to the opposite over adjacent, so 19 over b. when we do that, b is going to be equal to 19 over tangent 12.7. Well, I'm going to write here real quick. Oh, no, I can't write because it's a video, so I'm going to let that be. But essentially, you're multiplying both sides by b and then dividing both sides by tangent of 12.7. So when you do that in your calculator, you'll do 19 divided by tangent of 12.7. Make sure that your calculator is in degree mode, because then this jive will not work. So that's going to be 84.3. Now, I know it says round to 2 decimal places in the instructions for the length. I made a little error here, so we'll note that and deduct points from myself in the past, because this is the second time that I'm now talking this through. So now we're going to take a look at side C. Now with side C here, I'm going to use Pythagorean theorem. I mean, that's the easiest thing to do. You could use trig, but with the Pythagorean, I'm going to do 19 squared plus 84.3 squared. So that being said, oh yeah, I think I thought it was 18, but it should be 84.3. Let's correct that. And so with that being said, we'll get 7,467.49, but that's not an answer because we got to square root that guy. When we square root that guy, what we're going to get is 86.41. So if it would be 86.41, but if I think I just did the 1 decimal place again. So let's correct that next time. Now we're looking at bearings. Now bearings is our sense of direction. If I told you to go 72 degrees, you would not go 72 degrees in the second quadrant. You would actually go 72 degrees in the first quadrant more than likely. So we use bearings to describe that. Now bearings are all about the position of an angle. Now if I'm looking at north of this 35 and 72, whenever we look at describing bearings, whatever the main direction is, meaning that the axis that the angle is touching, so you have the north axis, the east axis, the south axis, and the west axis, that will go last. So if I'm looking at specifically 35 degrees here, I would call this 35 degrees north of east. Because imagine, if you travel east and then you look north, then you will be looking 35 degrees north of east, because east is that major direction. And there we go, 35 degrees north of east. So that being said, we're going to take a look at describing some of the other angles here. I think one thing that we can talk about too is another option for angle A. I'm sorry that this is going to be butchered. I can't remember what we did. Yeah, we talked about angle A. So for angle A here, one thing that we could talk about is this whole thing is 90 degrees. And since we have 90 degrees, we can subtract 35 from that, and that would give us 55. So another way that we could describe going from the origin to A is 55 degrees east of north. Both of these answers are correct. 35 degrees north of east and 55 degrees east of north. Both are correct. But the thing is, there's no but. You can use either one. That's fine. So how could I write or describe B? B, O to B could be looking at 72 degrees north of east. Or if I subtracted 90, it could be 18 degrees west of north. Oh, sorry, the first one I should have said is north of west, not north of east, sorry. If I look at O to C, that's essentially going south of west, and if I go to O to D, it's going to be 45 degrees south of east. Keeping in mind that the second measurement, so that west there, is the part where the angle is touching. So the angle is touching 16 degrees. Now, if I'm looking in quadrant 4 here, I can subtract 45 from 90 to find out that O to D would be 45. This is a special case where it doesn't really matter if it's south of east or east to south, because 45 degrees is exactly half of 90. So that's as far as angle measures go. We're looking at that. .45 degrees east of south. Now we do have the east axis and we do have the west axis, and the east axis again is just describing what the main part is. So it's all based on the final axis. So if I'm looking at 35 degrees, it's 35 degrees north of east because that's the major axis in the end. Now, I can look at A, I can look at B, and I can look at C. And it doesn't matter. Now, we're going to move on to word problems. And with word problems, we have, you need the RTD, read, think, do. So, first off, you leave your house and run 2 miles due west, followed by 1.5 miles due north. At that time, what is your bearing from your house? So the bearing is essentially the angle that we're looking at. Now, it's not really the angle, but it's the angle with a direction. So if I'm starting at the house, so I left my house, and then I ran 2 miles due west, I need to figure out how to go west, so I'm going to draw a compass. After I go 2 miles due west, I'm going to go 1.5 miles due north. So what we're looking for now is the bearing from my house. So from the location I am now to my house, what is that bearing? So the way that we describe it, going from the bearing to myself, the house to myself, I got to find the angle measure there. Now the best way to do this is from the point of location where we started, aka the origin. What is our bearing from there? So the bearing, I can either find the top angle or the bottom angle. Given that our angle, our triangle, is essentially formed on the bottom angle, I'm going to find that bottom angle. And the way that I find that bottom angle is through trigonometry. You guessed it, that's right, trig. So how can we find this? Which trig function? Tangent. We're going to be using a lot of tangent today. And so I'm going to do tangent is the opposite over the adjacent. So that'll give us 1.5 miles divided by 2 miles. And so we can do tangent theta is equal to 1.5 over 2. Once we take the inverse of both sides, that'll give us tangent is equal to tangent inverse, or theta is equal to tangent inverse of 1.5 over 2. Now we can input that in our calculator. And when we do that, we get 36.8 degrees. The reason that we're leaving it there, I mean, you could round it to the nearest whole number. You can call it 37. But here's the thing. This is not a final answer. You're going to get half credit on this. So what we have to do is label 36.8 degrees. Now let's think about the bearing. How are we? What is our location? What's the main axis? The west is the main axis. The west goes at the end. So we have 36.8 degrees north of west. That's our final answer. We've got 2 more word problems to go. We're doing it. We're getting there. So let's read it. A ship sights a lighthouse directly to the south. A second ship 9 miles east of the first ship also sights the lighthouse. The bearing from the second ship to the lighthouse is south 34 degrees west. But I'm going to rewrite this as 34 degrees south of west because that's the way that we're looking at it this year. How far to the nearest tenth of a mile is the first ship from the lighthouse? Now let's think. How far? How far? That's thinking. We read it. Now we're thinking. Think about what some things that we need to find. So first off, we need to draw a ship. Come on, draw the ship. There's a ship. All right, sweet. We got the ship. So we have a ship, and we are going to find out what else. The lighthouse is directly to the south. So because the lighthouse is directly to the south, we're going to draw a lighthouse directly to the south. and LH will just stand for lighthouse.